Let's start. Okay, so just in case you missed Monday's class, I had mentioned that we have a website for our course, so let me remind you again. The website for our course is http://bridgeport.edu/CS440, no spaces. Okay, and the username is ubstudent1 and ubstudent 2011. Okay. So every lecture will be videotaped, and usually by Thursday or Friday we'll have the video of the lectures for the week, and you can download it from the website, or even better, stop by my office, or I'll put the information on the website so that instead of downloading, you can simply copy the entire video onto your machine. It will be a lot faster. Okay. Also, as I mentioned, we have a graduate assistant for the course. Her name is Sumaya. Did I spell it right? Yeah. Okay. And Sumaya is over here. Okay, and Sumaya has some office hours, so any help you need, Sumaya is excellent in C#. She will help you. So her office hours are Monday 4 to 6 p.m., Wednesday 4 to 6 p.m., and room Tech 162. So this is the PhD cubicle area. So her office is in one of those cubes over there. So if you have any questions related to the assignment, related to not understanding any concept, please feel free to contact her. Let me put your email also. It's at the bottom. Okay, so the email for submitting assignments, as well as contacting Sumaya, would be CS440 fall 2015 at yahoo.com. Okay. And by the way, I do not use Canvas for this course. Most of your other courses will be using Canvas. I prefer running everything on our own server and using Yahoo for email submissions. Okay? So you'll be submitting all your assignments, projects to this particular email address. And if you needed to contact Sumaya, you can just email to her at this. So I'll keep this and post it also on the website. Okay, so last time I gave you a little bit of a history of object-oriented programming, and I explained how we went from unstructured programming, okay, where we were writing straight line code and jumping from one place to another. Okay. Obviously, if we are writing large software, it will become very difficult to track what we are doing and very difficult to maintain and upgrade it. So, as I explained in the last lecture, from here we went to structured programming, where we reorganized this straight line code into small functions and subroutines. So the controlling point, or the starting point, is a function called main, and rest of the methods or rest of the code is divided into, for example, function 1, function 2, function 10, and so on, right? Of course, each one will have its own meaningful name. Okay, so we discussed that if we divided this, and we had guidelines over here, for example, less than 50 lines of code. Again, a guideline doesn't mean if you went 60 lines, the code will not work. So less than 50 lines of code in each function or subroutine, right? In the main, all it will do is call a function, have it compute something and bring back the answer, then call something else, bring back whatever it did. So this is how we wrote programs in the structured style. For example, to this day, when you write a C language code, you're writing pretty much in this style, okay? Now, we discussed that one of the disadvantages of this style was you can declare some variables at the top, which do not belong to a function, but outside the main, outside any function, and these are called global variables. Meaning, any function, any subroutine can go and change the value of the variable or modify the variable. Or read the variable or change the variable, right? So that causes unreliability in large software development. One day it was producing correct results, somebody went and changed one of the variables, it stopped working or stopped giving you the correct result. And those type of problems are very difficult to debug, right? So this is where we introduce the concept of object-oriented programming. So object-oriented programming essentially is a reorganization of the structured code where we take some of these variables, some of these global variables, and some of these functions or subroutines which are closely related to these variables, and package them into a virtual box, and we call it a class, and we give it some name. For example, there could be a class called student, right? We may take a few more of these variables, a few more of these functions or subroutines which are closely related to these variables, and again package them into a virtual box and give it some kind of a name. So for example, this could be a class called employee. Okay, and again, just to give you a very tiny example, what kind of variables we will put if we were creating a class called student. For example, every student has a first name, last name, ID, right, and so on, address, telephone, GPA, and so on, right? All those things will be our variables over here. What are the functions that are closely related to these variables? For example, how many hours left to graduate? Okay, so that might be a function over here. If we needed to compute, for example, your balance that you owe to the university, that might be another function over here, compute balance, and so on, right? So very similar to an employee. What kind of data we'll have if we were creating an employee class, we can have the first name of the employee, last name of the employee, ID of the employee. If it is an hourly employee, how many hours worked? If again it's an hourly employee, what's the pay rate? Okay. Now, what kind of functions that will be closely related to this data? One function might be compute pay, and it may simply multiply the hours worked with the pay rate. One of the functions may be compute overtime. So if somebody works above 40 hours, maybe we pay time and a half. So whatever that formula is, we'll apply it over here and return that answer, right? Okay, so as we discussed in object-oriented programming, we'll organize our code so that we'll be writing many of these classes, okay? Depending upon what kind of application we are creating, we'll be creating classes representing the physical entities in that particular domain, okay? So for example, if you are creating a human resources application, okay, what kind of classes we will typically need? We will need, let's say, a class called employee, class called manager, a class called part-time employee, class called laboratory assistant. So whatever the organization is, what are the a class called vice president, class called president, right? So whatever physical things exist in the in that application, each one of them will be represented as a class. Okay. Now, one of the especially if you're new to this kind of programming, okay, one of the difficulty that a lot of people have is understanding the difference between a class and an object. So let me very quickly clarify that. Okay, so in object-oriented programming, first concept that we need is what is a class, okay, and what is an object. Okay, so think of a class as a template or as a category. Okay, for example, take a look over here. This is a marker, right?
Yeah.
This is also a marker. So this is also a marker. So I have 3 markers, right? So think of this way, we have a class called marker. So all it's defining is defining a category of physical entity, right? Okay, then further we may have several properties in this marker. Okay, what's the color of it? Okay, and again, the markers, you know, for example, this is a dry erase marker. Okay, so what is the capability of it? As an example, is it permanent or is it dry erase and so on, right? So what's the, when we write it, what is the thickness of the writing? You know, some are smaller markers, they are very thin. Okay, so for example, writing width or whatever, right? So these are the different properties a marker needs, right? So once we have created a marker, okay, if I have 3 markers, each one is different from the other, right? So then what we'll do is we'll create 3 objects of a class marker. So marker is the class. These are the 3 real entities, and those are what are called objects, right? So in popular object-oriented languages such as Java, such as C#, how do we create one object of it? Our syntax goes something like this. We will say marker M1 equal to new marker. Okay, so we have created, for example, one marker, right? Then we will say M1 dot color equal to blue. So this is the blue marker, right? So M1 dot capability equal to dry erase as an example, right? And so on. Okay, so what about what if I wanted to now represent the green marker, right? So then I will say marker M2 equal to new marker. And then M2, for example, dot color equal to green. Okay, so anyway, so approximately this is how we'll be writing our code. So what is marker in our example? What is marker? Marker is the class. Okay, what is M1? What is M2? And very similarly, if I create M3 over here for the black marker. So what do we call M3, M2?
Object.
These are called objects. So objects are physical things that exist. Okay, marker is basically defining what capabilities we need to represent for a physical entity. So the class by itself is useless, okay? Meaning until we create a real object, then we start to specify. At this point, nothing exists in the real world, okay? So anyway, so that's one difference between, or before we start, we need to have a clear understanding of it. Okay, so now let's come to what if we wanted to create, let's say, a university application. Okay, so let's try to identify what kind of classes we need to create to represent all operations of a university. Okay, so let's start listing the physical things that exist in a university. Okay, so let me. Okay, so for a university, does a university have students? Yes. Right? And every student has different data from another student, right? Every student has a different name, every student has a different address, different GPA, and so on. So before we do anything to a student, we will need to define a class called student. Okay, and in C#, just like Java, we'll say there's a category. Think of a class like a category. There's a category called student. Okay, and then you'll start listing all the fields as I just described. For example, first name, last name, address, ID, and so on. Right? Okay. Once we have created a student class, okay, now let's take the University of Bridgeport example. How many students do we have at University of Bridgeport? Let's say, roughly speaking, 6,000, okay? So what does that mean? We will need to create how many objects? Because each object represents one physical student. So 6,000 objects. So we will create 6,000 objects, and each object will store different data in it, right? Okay, is that the only thing we need to, only class that we need to create a university? What else university has? University has professors, right? Let's pretend there are 500 professors, okay? So we will create a class called professor, and then start listing what are the different fields we need to represent each professor. Other than the first name, last name, each professor belongs to a department. Each professor has some kind of a title: assistant professor, associate professor, and so on. Each professor may have a certain specialty. Each professor teaches certain courses, right? So after listing all the data that we may need, then how many objects of professor class we will create if we have 500 professors in the university? 500. And each object will contain different data, right? Makes sense? Okay. Very similarly, not only, we also have employees like secretaries, lab managers, and so on, right? So you can create another class called secretary as an example. Okay, and then start listing whatever fields we need for a secretary. And if we have, let's say, 200 secretaries in the university, we will create 200 objects, right? So anyway, you get the idea. So in object-oriented programming, once again, the starting point is identify what are the physical entities we need, okay? Then start creating each category, which we call a class. Then, depending upon how many physical numbers exist, you will create objects of that class, right? Okay, see, in programming, especially if you are new to it or don't feel as comfortable with programming, one of the hardest thing is people freeze. Okay, they say, where do I start? Okay, even though you can understand if somebody wrote the code what it did, but if it comes time for you to create, that's when there's that starting barrier that you have to cross. Okay, so I'll keep giving you hints. So the first thing that you need to overcome is right away identify what classes should I create. Okay, so step one in any large software development. What classes to create. Okay. Okay, and then you start one by one, and for each class, identify the fields needed. Okay, so today let's just put more detail into it. And we'll start with just one class, okay? We'll put some fields in it, okay? Then gradually, and again, let me also emphasize this, okay? When we write programs, even the best programmers do not know 100% what code will be needed, okay? So we all start, identifying, like I said, I need to create this class, okay? Then we all start by putting a few fields, and of course we may forget some. We may put a field that we may realize, no, this is really not needed, okay? So it's okay. Go ahead, put whatever you think makes sense, okay? Write the code, then you yourself will be able to identify, oh, I missed a field, I need one more capability. Or, no, I created this doesn't make sense. You'll go back and change it. That's perfectly okay. Nobody writes perfect code as they, put down or as they go to a computer, right? So now let me go to the computer. And let's pretend our goal is to create a university application. So everybody agrees we need to create a student class. Yeah. So I'll just start to create a student class. Once we create that, then I'll come back and identify the second class, the third class, right? Okay, so to give you a big picture where we are heading, see, first we will learn the fundamental object-oriented programming concepts, and also how are these supported in C#, okay? And again, to very briefly, so don't worry even if you haven't seen these before, we will put details. There are three main concepts in the basic object-oriented programming, and they are called encapsulation, inheritance, and polymorphism. So in the next few lectures, we'll completely understand these concepts and how do we program in C# to implement or to use these concepts, right? Okay, very briefly, what is encapsulation? Encapsulation, remember if you go to the English language definition, it means put it inside a capsule. Capsule, think of a capsule like a box, okay? So this is basically, think of it like putting in a box, putting things in a box, okay? Remember, as I mentioned, once we go to the object-oriented programming, right? We create some variables, we write some functions that are closely related to those variables, and then what do? We put them into a virtual box, okay? So creating classes, right? Where we declare some variables, we write some functions, and then create a virtual boundary over here and give it some kind of a name. So that's what encapsulation is called, right? So even though at first these may seem intimidating, but their meaning is very simple. So encapsulation is what class to create and how do we create the class, okay? So I'll start with this. Gradually I'll show you why we need inheritance, and we'll take the university application as an example so that everybody can relate to it. Then I'll go to the polymorphism and show you what that is and where it makes sense. And pretty soon, I guarantee, even if you are new to object-oriented programming, within a week, by the end of next week, you'll say, oh, this is very easy. Why was I afraid of it? Okay, so let's see. Okay, so as I emphasized in the last lecture, right? See, your goal is not just to learn C#, but be really good in programming in general. And C# is one of the languages. The good thing about programming is once you learn one language nicely, you can learn any language, switch to any other programming very easily, right? So let me emphasize one more time. You don't learn programming by simply reading or watching video or watching me explain things over here. Of course, in the beginning, concepts are important, but the only way you'll become really good with programming is sit down in front of a computer, start writing code, okay? So we'll be using Visual Studio, and University of Bridgeport has program with Microsoft called DreamSpark. And I think, do I have the instructions how to download on the 440 site? Okay,
Yeah,
so go to the CS 440 site that I mentioned. Take a look at the DreamSpark handout, go through the instructions, and obtain the latest version. Is called Visual Studio 2015. So professional edition or better, whatever they allow you to download, would be the best thing to download, right? So once you all, I'm sure most of you already have done that. So once you have Visual Studio 2015, okay, where did it go on my computer? Okay, so I launched Visual Studio 2015. Okay, in Visual Studio, we create projects. Every project goes into a separate folder automatically. Okay, so if you gave it a project name, let's say student app, it will automatically create a folder, right? So one of the first things I will do is I'll go to the C drive. I'll create a new folder. And let me call this folder CS440 Fall 2015. So all projects that I demonstrate to you over here will go in this particular folder. So each project will be a subfolder in this particular folder, right? So once I've created the folder, okay. Oops, what happened? Stay down. Okay, so let me run it again. Like it's asking me to enter my credentials. For the time being, let me do this. Let me run Visual Studio 2013. They are very similar for most of our work. Next time I will make sure the 2015 is all properly starting on my machine. Okay, so anyway, once I launch Visual Studio 2015, you will go to the File menu, New Project. Okay, so now once you go to File, New Project, okay, in Visual Studio, you can program in many different languages. You can program in C++, you can program in Python, you can program in C#, Visual Basic.NET. Since our goal is to learn C#, we will pick over here, see the language over here, Visual C#. We'll pick Visual C#, right? And then further, we can create web applications, desktop applications, which are called Windows applications. We can create code libraries and so on, right? Okay, most of the time in this particular course we'll be developing Windows Forms applications, but I'll also show you how to develop libraries and a little bit of WPF. Okay, so you'll select this one, right? So from the location drop down, you will go and, okay, since I created a folder just now, so let me browse to that. So I'll browse to the C drive and...
What is a Windows Forms application?
It's basically, yes, it runs as a desktop application. So as opposed to a web application where you go through a browser. Okay, so every screen is called a form basically. So anyway, so let me go to the CS 440 Fall 2000 folder that I just created. Okay, so once the location says our main folder, then for each project you will give it a name. Okay, so let me give our project a name of first. Okay, so usually the project names you will give them starting with a capital letter. So F capital IRST. So I selected Windows Forms application first, right? And if I click OK, so we'll create some infrastructure code for us, which gradually you will completely understand. So this is what it looks like in the beginning. Okay, the starting point in any program, remember as we discussed, is called main, right? So where's the main over here? If I go to the program.cs, you'll see here's the main. Okay, what does this code mean? Again, don't worry about it. Gradually you'll understand it. So for today, just pretend main has already been written for us. All we have to do is start creating classes and then somehow tie it to it. Okay, the only small thing that I'll mention right now is if you take a look at the main, which is found in program.cs. By the way, .cs means it's a C# file. Okay, you'll see application.run. So, and then new form 1. Okay, so that means in the very beginning, it will run a class called form1. So anytime we say new form, new and then name of some class, we create an object of that class, right? Okay, so what is form1? If I double click on form1, okay, form1 looks like this. Okay, so if I run it, how do we run a program under Visual Studio? You go to the debug menu and you have two options, start debugging or start without debugging. So just say start without debugging for right now. So I haven't written any code yet, but this is what a form looks like. Okay, so it is some user interface where we can further put a lot of things over here, and we can minimize, maximize, and if I exit out, it will close the application, right? Okay, so once again, in the program.cs, it basically says run form1 as our start. Okay. And what's form1? Form1 is this part over here. Okay, now for those of you completely new to Visual Studio, okay, the top right-hand corner where you see there's a solution over here. Okay, solution is first. Then underneath it, there's something called first. That's the project. Okay, so the terminology or the capabilities go something like this. Okay. In Visual Studio, VS is like abbreviation for Visual Studio. Okay. A solution contains projects. Okay, so it can contain one project or it can contain more than one project. Okay. Most of the time, when you are creating your applications in the beginning, one solution will contain one project. Towards the end of the course, as I will show you how to create libraries and so on, and especially if we wanted to debug, So your form may call a library, which is a separate project. So if we put them in the same solution, you'll be able to see it's very easy to debug. Okay, so for right now, don't worry about too much about it. Basically, whatever classes that you create will be added to a project, not to the solution. Okay, so first concept is classes that we create will be added to a project and not to a solution. Okay. So what do we add to a solution once again? Another project. Okay. But to a project, we'll simply add classes. Okay. So now let me come back to Visual Studio. Okay, and once again, this is called, this right-hand corner over here is called Solution Explorer. Okay, and so from here we can easily navigate from one file to another. So all you have to do is just double-click on a file, and then this part will show you the contents of that file. So once again, if you wanted to go to program.cs, just double-click on it. If you wanted to go to app.config, just double-click on it. So this is what's in app.config. If you wanted to see what is our user interface so far, double-click on the form. Okay. So now let's start with creating a simple class called student and see how we can run it. So you'll see it's very easy. So will I be adding a class to the solution or to the project? Remember, the top is the solution, then below it is the project. So because classes are added to a project, I will right-click on the project. So once I right-click on the project, you'll see there's an add option. Okay. So now there's a couple of ways I can add a class to the project. So if I right-click on the project name, add, I can simply pick a class. Okay, but there are many other things that we can add to a project. So if I go to a new item, it will give me all options that, so if I click on new item, okay, so as you can see, there's a huge list of things that we can add. We can add a bitmap to a project. We can add a class. We can add a class diagram. We can add an icon, installer, interface, JavaScript file. So tons of options over here, right? So sometimes we'll be going over here as we keep going and adding things other than a class. So that you can very easily look for what type of thing you want to add to the project. First thing that I will recommend, once you have the Visual Studio ready, where it says sort by, okay, normally it has a default setting, okay, which is, in my opinion, kind of tough to find because it's not in any particular order, right? So change this setting to name ascending. Now it's all alphabetical, so if you wanted to add a class to the project, you'll see A, then B and C, so you can just pick a class. As soon as you pick a class, it will ask you for a name of the class, okay? So name of the class I will highlight over here and call it student with a capital S. So as I mentioned in the last lecture, whenever you program in any language, regardless of C++ or Java or C#, you should always try to follow the conventions of that language, okay? So the convention in C# is, okay, class names start uppercase, okay? The functions inside the class also start uppercase. Okay, and by the way, when we write a function inside a class, In the object-oriented terminology, we call it a method. Okay? So sometimes if you hear me saying a method or a function, it's the same thing. Okay? Okay, and then private variables inside a class appear or start lowercase. Okay. Then public properties. Remember we discussed in the last lecture a property was a wrapper for a get and a set function. Start properties. Okay. So anyway, try to follow these conventions. If you take a look at this part, for those of you who have a Java background, what difference do you see from a convention point of view in C# and Java? In Java also,
Functions.
class name start uppercase. Okay. This is where the difference is in the convention. In Java, the method name start lowercase. Okay, so rest of it is the same. Okay.
Public properties also.
Yeah, in Java you don't have properties, so so that's one small difference, right? Okay, so now let me go start creating a class. Okay, so let me cancel here one more time. So let me show you again. So to add a class to the project, I'll right click on the name of the project. I'll say add. Again, I can directly go to a class or go to add new item, select the class, and then give it a name. So I'll give it a name, student, and .cs is automatically needed or is needed because the language is C#. Okay. So anyway, once I click add, as you can see on the right hand side, they did create another file, right? So it created a file called student.cs. And by the way, at the bottom, this is called the output window. Okay, you can always X out any one of these windows. So I typically X out the output window so that I can see more screen. And if you needed, you know, as for some reason you needed that window back as you're running the program, in the view menu, you can always go and find, see there's an output, so it will come back. So don't worry, even if you X'd out something, so you can get it back, okay? So for example, if you exit out, so take a look at my screen, if I X out the properties window. So again, you know, if you're not finding that properties window, go to the view menu again. If you don't see properties window anywhere over here, go to this other windows. Okay, is there a property window, property manager? Okay, maybe it's on the main screen. What happened to the property window?
Property manager is not.
Yeah, but that's a different, that's not a property window.
I think if you go to window in the top, right?
I've done it many times before, but the property manager, no. View. So anyway, first let me go to the View with Solution Explorer.
Properties windows is down
Down there.
Property. Right at
Down,
the
down,
end,
down.
right
Down.
at the
All
end.
the way down.
Bottom.
Look at the bottom.
At the bottom.
Yes, that's it.
Okay, there's the Properties window, and now we need the Solution Explorer. That's the Team Explorer.
So last view.
you guys see solution?
You know,
It's if
Versus
a tab there.
another one.
Another tab.
There's another.
Next to the theme
Now-
part,
now-
It's there.
Go down. Go down.
Beside the TV.
Oh, sorry, over
There
here,
you go.
yes, okay. So anyway, all I'm trying to show you is, even if you close something, you can always get it back, right? So through the view menu, you can get it back. So anyway, so now let's come back to the student class. Okay, now, begin curly indicates the start of a particular section. So in this case, this is the start of the class, and this is the end of the class, right? And then as you can see, every class is written inside a namespace. What exactly is a namespace? We'll talk about it more in detail. Okay, for right now, think of it this way. Pretend there's a bigger box that's called the namespace. Inside that bigger box, there is the class. Okay, so if you take a look at this n curly, see if you right-click on it. If you click to the right of it, even though on my screen, I mean on this one you cannot see, but what it does is it highlights the matching begin curly. So this is the end of the namespace basically. Okay. This is the end of the class, this is the beginning of the class. So any code that we write, we will put inside this begin curly, end curly. So let me go to that class. Okay, so now let's start writing the code. What kind of fields we need for a student? First name. Okay, remember in the last lecture we discussed in C#, if we declare a variable, is it hidden inside the class or is it public? Meaning, is it visible outside? Remember we had private. So the default is private. So it's your choice. You can put private over here as an example. Okay. So there is a keyword. One of the things you will notice is all keywords are appearing in what color?
blue.
Blue color, right? And if you don't put it over here, private, the comments are same as Java, C, C++. So the comment is // This is for our own identification. The compiler or the computer ignores these. So default is private in C#. Okay, so that's why we don't have to put private over there. Right, as we discussed in the last lecture, now this will be useless to the outside world. So that we can access it from the outside world, we need a get and we need a set. Okay, let me show you two ways of writing it. One way is, remember we discussed as a property. So I will say public first name, then begin curly, end curly. Sorry, I forgot to say string. First name, okay. Now, sometimes as you are writing things, right, the indentation is good for our readability. So sometimes this may get completely, this curly may go over here. So even though it's still okay, but it doesn't look nicely. So if you wanted it to be properly indented, so you can easily see which one starts where, ends where. Okay, all you have to do is retype the last, the surrounding curly brace. So if I highlight this one and delete it, backspace on it, and retype it, so take a look what will happen. It immediately aligns everything properly, so it's easy for us to see. Anyway, so public string first name, then if you rewrite get, is return first name, and then set is first name equal to value. As we discussed in the last lecture, value is a keyword, so if we are trying to modify, it will get stored in this first name. So our real data in this student class is only this first name with the lowercase f. That's the only storage that we have. So what are these things over here?
Okay, this one.
This is a function, this is a function, okay? And what is this then over here?
Property.
But it's simply a wrapper for these two. So it's not a physical entity. When we trigger this, it actually, all it does, it redirects either to the get part or set part. So that's all it does. But as far as computers' memory is concerned, only this is the real memory where data will be stored, okay? So that's why once we say